All right, we are going to talk about differentiating between speed, velocity, and acceleration. Now, the key word here is differentiate, so you need to think about what that word means. It means to tell the difference between. So the three words we need to tell the difference between are, speed, velocity, and acceleration. You have some notes that look similar to this. It's not the best picture in the world, but they're either on pink paper on there or they are on white paper. And the topic says speed, velocity, and acceleration. Go ahead and put whatever today's date is at the top so your notes are completely accurate. And then we are going to go ahead and get started. All right, the first question asks, how does one identify the speed of an object? Well, that's what you see here on the screen. How fast an object is moving is simply called speed. A second definition could be speed is how far something travels in a distance in a given amount of time. Those are your next two blanks. Sorry, part of the picture got cut off there. The formula for finding speed is going to be distance over time. Speed equals distance over time. Here is a much nicer looking way than the way I wrote it. Speed equals distance over time. Make sure you have that underneath where it says what is the formula for finding speed. Now this next thing is very important. This picture here, find some space maybe on the left column underneath where it says how does one identify the speed of an object. This is the speed triangle. This is how we solve for different variables in the speed formula. So in the speed formula you have speed, which is the S, you have D, which is distance, and T, which is time. So basically the way that this works is like this. If they give me a problem, there's my speed triangle again, and they tell me that I have a distance of 10 meters and I have a time of 5 seconds. Well, they've given me the D and they've given me the T, but they've not given me the S, so that's what I'm looking for. That's the variable that I have to find. So I use the triangle this way. I'm going to cover up the thing I'm looking for. So I must set the triangle just like this all the time. The D must always be on top in the speed triangle. So since I'm looking for S, I'm going to cover up my S. That leaves me with D on top of T, and I know that in math, when I see things that are set up like fractions, they are also division problems. The number in the top is the number that goes inside the house. So my D is 10, and I'm going to divide it by my T, which is 5. And I know that 5 goes into 10 2 times. So my speed is going to be 2, but I have to have a unit. And one of the definitions for speed is distance over time. So the distance they gave me is meters, and the time that they gave me is seconds. So my speed would be 2 meters per second. So your next thing asks you for how it looks. It says, what does it look like? So it looks like this. It's meters per second or kilometers per hour. Those are both examples. So an example of a speed would be like this geese or this goose flying at 4 meters per second. That's a speed because I have a distance and I have a time. I skipped one of the blanks, so just go back up for a second. Underneath, the very last dot in the first section says that the unit for speed is meters or kilometers, which is your distance, and seconds or hours for a time. So everything must have some unit of distance and some unit of time. So that could be meters per second. It could be kilometers per second. It could be miles per hour. It could be kilometers per hour. Okay? It could be feet per second. These are all different types of speeds. Okay, next we want to talk about how does one determine the velocity of an object. Velocity is a little similar to speed, but velocity is a term used when referring to the speed and so we have what's called vectors, and vectors are simply arrows. They can be used to show the direction of an object's motion, kind of like how we looked at balanced and unbalanced forces. You have some type of force with an arrow, and the arrow shows you the direction of the force. So vectors work the same way. They're showing you the direction of the object's motion. It's the same thing. The next thing asks you for the velocity formula. The velocity formula is simple. If velocity is speed plus direction, then all you have to do is know your speed formula. And what's speed? Well, speed, or S, equals distance. Having a hard time writing with this iPad again, guys. I apologize. Speed equals distance over time. And then once you're done, all you have to do is add a direction. So examples of velocities that you can write down. How about meters per second west? Okay. Well, my speed is going to be meters per second, but velocity is speed plus direction, so meters per second west. West is that direction. Another example could be kilometers per hour south. Okay. Or miles per hour up, down. Those are both directions as well. So make sure you know your distance and your time and your direction. So in kilometers per hour, my distance is going to be kilometers. My time is, you guessed it, hours. My direction is south. What about in miles per hour? It's written a little different. If we don't write it this way, which is the traditional way you guys are used to seeing it, you can do miles per hour this way. But it still has a distance and a time in it. So distance is miles, time is hours, direction is going to be up. All right, lastly, we're going to define the acceleration of an object. When a force is applied to a moving object, so when a force is applied to a moving object, the object can accelerate by doing four things. It can speed up. We call that positive acceleration. It can slow down. That's negative acceleration. It can stop, or it could change directions. So you heard me say that speeding up is positive acceleration, slowing down is negative acceleration. Well, a lot of times you guys hear if they say they're going to slow down in a car, they're going to decelerate. Decelerate is not a scientific word, so we're going to use the terms positive acceleration and negative acceleration. Never deceleration. Deceleration is a bad word, so we're not going to say that. So what are we going to say instead? We're going to say negative acceleration. Your next dot says that any change in motion, switch colors here for you guys. Any change in motion of an object is called an acceleration. Any change in motion is called an acceleration, okay, which is our third term that we're differentiating. Okay, acceleration is measured in meters per second, or meters per second squared. That's something you guys definitely don't want to forget. All right, so the last thing we need to get is you need 5 examples of acceleration. So one thing you could do, stepping on the brakes, okay? So remember there's 4 things you could do. You could speed up, positive acceleration. You can slow down, negative acceleration. You can stop, or you can change direction. So stepping on the brakes will be slowing down, so that's negative acceleration. A second example could be pedaling your bike faster. That's speeding up. That's positive acceleration. How about this one for a third example? Dropping your lunch tray to the floor. As you drop it to the floor, eventually it's going to stop. So that's another example of an acceleration. Okay, a dog chasing its tail. The dog is speeding up, trying to get to its tail. That is an example of acceleration. It's constantly changing direction because it's going around and around in a circle. Okay, a roller coaster climbing to the top of a hill. Think about it, when you're on your favorite roller coaster, it is slowly traveling up to the top. So it's actually slowing down. So you have a bit of negative acceleration. Then once you go over down to, well, as I foresee it sometimes, possibly a very scary moment, it speeds up. So it's going to be a positive acceleration going down the hill. So that's pretty much it, guys. At the bottom, it asks you to summarize and explain in your own words how these three physics concepts are different from one another. So quick review. Speed is going to be distance over time. S equals D over T. Remember your triangle. D always goes at the top. S and T are at the bottom. Then it must be in a unit of distance, a unit of time, meters per second, kilometers per second, examples. Okay, then we have velocity, which is speed with a specific direction, so that could be like meters per second south, it could be kilometers per hour up. And then lastly, you have acceleration, which is positive acceleration, speeding up. You have negative acceleration, which is slowing down. You can stop or you can change directions. All right. Hope this helps. Make sure that you focused and paid attention so you can be successful in this next part of our unit.